Welcome. In this video, I will be formulating and solving a binary LP model for this capital budgeting problem involving 5 projects over 4 years. These are the cash outlays in millions of dollars over the 4 years for the project, and the budget allocation for each year is given here. The objective is to maximize the expected net present values. Unused funds in 1 year can be carried over to the following year, and we have additional logical constraints here. We begin by defining the decision variables. Let xi equal 1 if project I is selected and 0 if not selected, where I equals 1, 2, 3, 4, and 5. In essence, if x1 equals 1 in the solution, then project 1 is selected, and if x2 equals 0, then project 2 is not selected. Since the objective is to maximize total NPV, the objective function will be to maximize 10x1 plus 18x2 all the way to 12x5. For the year 1 budget constraint, we have 5x1 plus 11x2 all the way to 9x5, which cannot exceed the first year budget of 32 million. For the second year, normally we will have 2x1 plus 8x2 to 6x5 less or equal to 30 if there is no carryover from year 1. But because we have the possibility of a carryover, we have to add the leftover funds from year 1 to this 30 million. Now the leftover funds from year 1 will be 32 minus the left-hand side of constraint 1, which is the actual amount spent in year 1. And on rearranging that, we have the constraint for year 2 as given here. Observe that each coefficient of this year 2 constraint is simply the sum of year 1 and year 2 outlays for each project, and the right-hand side is the sum of the budgets for both years. Similarly, for year 3, if there is no carryover from previous years, we would have 2x1 plus 6x2 to 1x5 less or equal to 15. But again, we need to add to this 15 the carryover funds from year 2, which is 62 minus the left-hand side of year 2 constraint. And that simplifies accordingly. You can see that the coefficients are the sums of the year 1 to year 3 outlays for the project. It follows that the coefficients for year 4 will also be the cumulative outlays and budgets from year 1 to year 4. Next, we formulate these logical constraints. Project 2 cannot be selected unless project 1 is also selected. This is a conditional constraint in which project 2 depends on project 1 to be selected. So we say x2 is less or equal to x1, which can be rewritten as negative x1 plus x2 is less or equal to 0. The next one says projects 4 and 5 must not be selected together. And we write x4 plus x5 less or equal to 1. This is a mutually exclusive constraint where we can have at most one of the projects, but not both. Finally, at least one of projects 3, 4, and 5 must be selected, which we write as x3 plus x4 plus x5 greater or equal to 1. Putting all these pieces together, we have the formulation of the binary problem as seen here, where each xi is binary, that is 0 or 1. Next, let's solve the problem using Solver in Excel. Here we have the table of values and the LP formulation of the problem. I'll begin by creating the variable title here. Equals project 1, drag to the right. I'll select the cells under them for the decision variables and fill with yellow color. I'll call it selected with a question mark. Then for the objective function coefficients equals NPV and drag to the right. Center and bold. Then for the constraints, I'll type year 1 here. Drag down to year 4. For the coefficients, I wanted some formula that will automatically create cumulative values for the years. I'm going to start with equals sum. Click on the first value in cell C3, then type colon, which automatically creates another C3. That is, we want the sum to start at C3 and end at C3. However, to ensure that I can copy the formula to the rest of the cells, I will place a $sign in front of 3 here. This will ensure that when I copy to the rest of the cells, the sums will always start on the 3rd row for each project. Enter. And when I drag it down to year 4, you can see that it computes the cumulative values. 5 plus 2 is 7, 7 plus 2 is 9, and 9 plus 0 is 9. Now I can grab the handle and drag for the rest of the projects. Now I'm going to select the budget and drag 2 columns to the right. Now for the first logical constraint, where project 2 requires 1 to be completed, the coefficients are -1 and 1. For the second, projects 4 and 5 are mutually exclusive and we have coefficients 1 and 1. For the third one, the coefficients for 3, 4, and 5 are 1, 1, and 1. Next, I'm going to place the objective function here. I'm going to use equals sum product. Select the objective coefficients, comma, then select the yellow cells. Enter. I'm going to shade it light green. Similarly for the first constraint, equals sum product, select the coefficients, comma, then select the changing cells. But this time, I'm going to press F4 to lock down the changing cells. Enter. Then drag it down for the rest of the constraints. I'm going to shade the constraint formula cells light blue and double-click the last cell here to ensure the formula is copied correctly. Next, I'm going to place the constraint signs here for visual purposes only. The first 6 constraints are less than constraints, and the last one is a greater than constraint. The right-hand sides for the logical constraints are 0, 1, and 1. The setup is now complete. To solve it, click the Data tab, and you should have Solver here if you have it activated. Otherwise, right-click anywhere on the ribbon, click Customize the ribbon, click Add-in, click Go, select Solver Add-in and click OK. Next, I'll click the Data tab and click Solver. For the set objective, I'll select the green objective function cell. I'll leave max selected since this is a maximization problem. For changing cells, select the decision variable yellow cells. Next, I'll click Add to add the constraints. Since the first 6 constraints are less or equal constraints, I'm going to select the formula side of all less than or equal constraints. Ensure the less than or equal sign is selected, then select the right sides. Click Add. Select the left side of the last constraint. Select the greater or equal sign, then select the right-hand side. Click Add. Next, I'll select the decision variable cells. Click the drop-down and select Binary. Then click OK since I'm done adding the constraints. Next, I'll click this drop-down and select Simplex LP. Then click Solve. I'm going to select Answer Report and click OK. And here is the solution. You can see here that projects 1, 2, and 4 are selected, and the objective function value is 53. You can also see the objective function value here in the answer report. The selected projects here, and the binding and the non-binding constraints can be seen down here. Thanks for watching.